Hi, my name is Robin and you are welcome back to my channel. In this section, I will be dealing with linear inequalities and line intervals. Let's dive right into it.
Now, I will quickly refresh your memory in what we did in part 1. 6 greater than 4. It simply means 4 less than 6. 6 is greater than 4 simply means 4 is less than 6. So here, if I tell you 4 is less than 6, that simply means 6 is greater than 4, which is the same thing that we have here. Now, you recall, this sign means greater or equals to, and this means less or equals to. Greater or equals to simply means not less than. Okay? Less or equal to simply means not greater than. So, if I have 6, okay, if I have x greater or equals to 6, okay, x is greater or equals to 6. So what this one simply means is telling me that x is not less than 6. That is what it means. If I have x is less or equals to 7, it simply means x is not greater than 7. Recall that if I have a greater than b, it also means b greater than a, which is what you see here. Alright? If I say a minus b greater than 0, you already know that for me to write a, or I can say this will be minus b plus a greater than 0. This is minus bracket b minus a greater than 0, right? So recall that when you have a negative, what happens? The sign changes, right? So this will be b minus a. So a minus b greater than 0 simply means b minus a less than 0. You already know this from part 1. Now, let's start with part 2. And I want you to pay really good attention to everything we are going to do here. Hope you enjoy it. Let's get into it. Let's start with linear inequalities. Here, we'll be dealing with linear inequalities in one variable. One variable simply means x or y or z. For an example, if I have 3x plus 6 is equals to 12. This is a linear equation. Equation because of the equality sign. And why is it linear? This is the power of x is 1. That is why it is a linear equation. But how many variables do I have here? X. Only one variable. So this is a linear equation with one variable. So if I want to change this now to linear inequality with one variable, that would be 3x plus 6, and I will just use the inequality sign here. So in this video, we'll be dealing with linear inequalities with one variable. Now let's solve these linear inequalities. The first one, A, 3t less than 6. Now here, you can see that 3 is multiplying t and is less than 6. That is what it means. So for me to be able to have only t on these sides, I have to do the opposite of multiplication. And opposite of multiplication is division. So it simply means I have to divide both sides by 6. So 3 will cancel 3 here. Because I'm dividing both sides by positive 3, the sign remains the same. So t is less than 3 here is 2. So t is less than 2. Now let's check b. Minus 3t less than 6. Here, minus 3 is multiplying t less than 6. For me to have only t here, I have to divide by the opposite of multiplication, which is division. But in this case, I'm dividing both sides by minus 3. Okay? This will cancel this. Now, because I'm dividing both sides by negative value, the sign, which is less, will change to greater. So how many can I get here? That is minus 2. You see the difference between A and B. Okay? Then let's go to C. Question C. Question C. 4t minus 1 less or equals to 3. Okay, the first thing is that I want 4t to remain here. This is minus 1. So I have to add the opposite to both sides. The opposite of minus 1 is plus 1. So I'm adding plus 1 to both sides. Okay? So minus 1 plus 1 we cancel out. This is 4t. Less or equals to 4. Now in this case, I have to divide positive 4. So this divided by 4. And this divided by 4. So in this case here, our t will be less or equals to 1. Now question D. 3z plus 2 greater than z plus 3. Okay, so here, let's leave z on this side. So that means I have to take away plus 2. Opposite of plus 2 is minus 2. So I'm adding minus 2 to both sides. Okay? So this one will cancel this. So this is 3z greater than z. Plus 3 minus 2, that is plus 1. Now, I want to take z away from here. Okay? And this is plus z. That simply means I have to add opposite of plus z to both sides. That is minus z. So z minus z plus 1. So this will cancel this one. 3z minus z, that is 2z greater than 1. So now I want only z here, so I have to divide through by positive 2. And because you are dividing through by positive 2, the sign remains the same. So z is greater than 1 over 2. E. 5 minus 2y less or equals to 9 plus y. Okay, I want to take away 5 here. This is plus 5. So taking away plus 5 here, I have to add minus 5 to both sides. So adding minus 5 to both sides. So this one will cancel this one. So this is minus 2y less or equals to 9 minus 5. That is 4 plus y. Now, I want to take away y from this side. So I have to add minus y to both sides. Minus y to both sides. So this will cancel this. So this is minus 3y less or equals to 4. Now I need y here, so I have to divide through by negative 3. And dividing through by negative 3 tells you that the sign has to change, right? So if I cancel this one here, y will be greater or equals to minus 4 over 3. Now question F. This is different from the rest. Minus 3 less than 5 minus 3x less or equals to 11. Whenever you have a question where you have more than one inequalities and you're asked to solve, what it means is that you pick the first left and right, and you pick the second left and right. You can see that. So what it means is that the first one you're picking, which is this one here, is minus 3 less 5 minus 3x. And the second one you're picking, which is this one here, is 5 minus 3x less or equals to 11. So you have two equations to solve here. Okay? Now, let's assume I want to leave minus 3x here. So I want to take away 5. This is plus 5. That means I have to add minus 5 to both sides. So this we cancel this one here. This is minus 8 less minus 3x. Now, I'm looking for x. I have to divide through by minus 3, which is the negative. That means the inequality sign will change. So I'm dividing by minus 3. Okay, I'm dividing by minus 3. So which simply means this is 8 over 3. The inequality sign will change. And this is x. So this is 8 over 3 greater than x. That is still x is less than 8 over 3. That is the first one. Now for this one here, I will quickly do this one. You know already what I'm doing here. So 11 with that, 6. Divide through by minus 3. That means the inequality sign will change. So you have, therefore, here, therefore, x is less than 8 over 3, or x is greater or equals to minus 2. So now let's take types of intervals. In inequality, we have two kinds, or we have two types of intervals. The first one that we have is the infinite intervals. Infinite interval. This infinite interval can be classified into two. You have open infinite interval and you have closed infinite interval. Then number two, you have the finite interval. I'm going to explain this. So in explaining this, let's assume I have x is greater than 3 and x is greater or equals to 3. Okay, let's take a number line. A number line with x-axis. So this is 0. This is 1. This is 2. This is 3. And this is 4 and above. Okay? 4 and above. This is minus 1, minus 2, minus 3, minus 4 and above. Okay? So x is greater than 3. X is greater than 3. That simply means any number that is greater than 3 is x. So in a number line like this, I will put greater than. Whenever you're talking about greater than or less than, we use this notion. Okay? Whenever you're talking about greater or equals to, less or equals to, we use shaded. Okay? So now I'm talking about greater than 3. So I'm using this. Okay? The same thing as is called open, and this is something as saying close. So greater than 3 means any number that is greater than 3. Okay? That is everything here greater than 3. Okay? But you'll be like, but why are you starting on 3? Why can't you start from 3 point something? Because you're talking about x greater than 3. Don't worry. I will tell you for the next one here, which says x is greater than 3. If this is 3 now, x is greater or equals to, you can see, or equals to. For the fact that it is or equals to, I will shade it to show that it is including that number. So it's including 3 and is greater than. You see the difference now? The first one here, x is greater than 3, meaning 3 is not included, right? Because it's greater than 3. So you are going to use open circle and it's greater than. But the next one is x is greater or equals to. That means is including 3. So you are going to use close and is greater than. Now, because the x value is continuous, because anything greater than 3 satisfies this inequality. Because it is continuous, it becomes infinite. Because it is continuous. For this one, also, everything greater than 3, because it's continuous, it is infinite. So you can see, infinite interval can be open or close. Now, let's check this. X. Okay? Let's say 2 is less than x. Or let me put it this way. Let me put it this way. Okay? X is greater than 2 or x is less than 4. Okay, let's check this interval now. This is 0, right? So I have 2 and I have 4. Okay? This is x-axis. Now, x is greater than 2. X is greater than 2 means here. X is greater than 2. Okay? The line goes like this. Anything greater than 2 goes like that. Right? Okay. But I don't want to draw it. I don't want to draw it to cover my 4. So let's say I stop somewhere here. Okay? Let's say I stop somewhere there. I don't want to draw it to cover my 4. So that is x is greater than 2. Remember, not shaded. So this is open. Then x is less than 4. X is less than 4. Okay? What is less than 4? I go to the left because every number from here is less than 4. So less than 4. Once I draw less than 4, you can see it will connect with this line here. Okay? So that shows that this is not infinity. It is finite. It is a closed, it is a combined system. So in this case here, I can tell you x is greater than 2. It simply means 2 is less than x. That is what it means. If x is greater than 2, that means 2 is less than x. And that same x is less than 4. So this is the combination of what we have. So this is 2 less than x less than 4. You can see that. In a case where I have something like x is greater or equals to 2, or x is less, or x is less than 4, for an example. Okay? Let's use x is less than 4 here. X is less than 4. So in this case, I have 2 and I have 4. And my axis is x. Okay? So x is greater or equals to. That means shaded, right? Shaded. And the line goes to the right because it's greater than. Okay? I don't want to go above my 4. Then x is less than 2. X is less than 2. That is open. And the line goes to the left. You can see it is combined. So this is shaded while this is open. So this is closed while this is open. You can still call it that way. So x is greater or equals to 2. That means 2 is less or 2 is less or equals to x. And that same x is less than 4. So this is 2 less than x, less or equals to x. And that same x is less than 4. So you can see the difference between this one and this one. Okay? So it is about you just knowing that less or less, greater or less is open, not shaded. Greater or equals to, less or equals to is close, shaded. Now let's take questions here. Now let's take this question. Given I (2 bracket 3 minus x greater than 9). Okay, so we can open the bracket here. 6 minus 2x greater than 9. You already know how this works, okay? Because this is linear inequality. So if I divide this by -2, the inequality sign will change. So here, this is x-axis, and we have -1.5. Or you can write it as -3/2. So he's saying x is less than. For it to be less, that means not shaded, right? Because -1.5 is not included. So x is less than 1.5. So this is less than 1.5. So this is continuous here. Okay, that is for that. Now let's see the next one. Then we'll now read the whole question to see what we're asked to do. This is 3x plus 3, 4x minus 2, so equals to 6. 3x plus 4x, that is 7x, plus 3 minus 2, that is plus 1. So this is 7x, this is 6 minus 1. I'm just doing it very fast now. Divide through by 7, which is positive, so the inequality sign remains the same. So 5/7. Okay? 5/7 is still the same thing as, if I put that one in decimal, that will be 0.71. 0.71. So x is greater or equals to 0.714. So if I do this like this, and I say this is 0.714, or you say 5/7, remember, it's greater or equals to, that is shaded. So it's greater in that way. Now, if I were to put this together on the same number line, I want to put this together on the same number line. Okay, this is 0. This is -1.5. And this is 0.714. Okay, we already know that this one is less. It goes to the left. Okay, and this one is shaded. It goes to the right. So you can see that it is not combined. And for the fact that it is not combined, because whenever you have a combined inequality, which is what we saw in the last example where it was finite, it was close together. You understand? This one, you can see the x value here and the x value here, they are not together. So in this case, this is when we use or. Okay, this is when we use or. But in a case where you have something like this, I'll quickly give you an example here. -2 and 3. Let's say this one goes like this, and this one comes like this. You can see this is joined together. So in this case, we use and for this. Okay, so now this says show the intervals in which x can lie if it satisfies I or 2, Roman figure 2, and if it satisfies I or Roman figure 2. We know it does not satisfy this one because this is for a combined inequality, just as I explained here. But because this is not combined, this is or, so it satisfies or. So it simply means the x values satisfies this. The x value will be the value that satisfies this one and that satisfies this one here. Now, let us pay attention. Find the intervals in which x can lie if, for the first one, A, 3x minus 1 is greater than 5, or 1 minus 2x greater than 4. The first thing you need to notice here, to use the word or. Or means not combined. Not combined simply means the value of x that satisfies this linear inequality and this linear inequality is not combined. So that is what we are interested in, not combined. So here, if I solve this one, 3x greater than 5 plus 1, 3x greater than 6. So divide through by positive 3, so which means that the inequality sign remains the same. This is x is greater than 2. Here, this is minus 2x greater than or equals to 4 minus 1. Minus 2x is greater or equals to 3. Divide through by negative 2, which simply means the inequality sign will change. So x here is less or equals to minus 1.5. Now, let's see. If I put this on a number line, this is minus 1.5, and this is 2. So x is greater than 2, not shaded, right? Greater than 2. And x is less or equals to, that is shaded, less or equals to shaded, then less or equals to on this side. You can see now it is not combined, and that is the solution that we want because it is or. Okay, but in a case where that means the value of x that satisfies this inequality and this inequality is in here and is in here, so it is not combined. So all means not combined. For B, pay very, very much attention now. So this says and means that is combined. We want it to be combined. So and means combined. It tells you that the value of x that satisfies this inequality has to be combined. So this is 3x minus 1 greater than 5 and 1 minus 2x greater than 4. So we already solved this one already. We got x is greater than 2, and we already solved this one already. We got x is less or equals to minus 1.5. And we drew already the number line. This is the number line. You can see that the number line is not combined, right? So it simply means for this question, it cannot be hand because it cannot be combined. So what do you say in this case? You will say no solution. Why are we saying no solution? Because in the number line, you can see the value of x that satisfies this inequality is not combined. That is why it is no solution. Because and means it has to be combined. Something like this, where you can actually combine the value. But here, it is not combined. So the only value of x, the values of x that satisfies this inequality is going to be or and not hand. Let's take one more question. Now, let's solve this inequality. Minus 3 is less than 5 minus 3x, and it's less or equal to 11. You already know that. I'll pick the first left and right. Okay, and that is minus 3 less 5 minus 3x, and I will pick the second left and right, and that is 5 minus 3x less or equals to 11. So I have two linear inequalities. So let's solve this one here. Minus 3 minus 5 less or equals to 3x. This is minus 8 less or this is less 3x. Okay, so I will divide through by minus 3. Because I'm dividing through by minus 3, you already know the inequality sign will change. So this is 8 over 3 greater than x. This simply means x is less than 8 over 3. That is what it means. And what is 8 over 3? Let's put that one in decimal to be easier. That is 2.66. For this one here, we have this, divide through by -3. You already know what is going to happen if you divide by negative value. The inequality sign will change. So here, let's put this on a number line to see what happens here. Okay? So you have -2 and you have 2.66. So x is less than, so it's open or shaded. Okay? And it goes this way. And x is greater or equals to -2. Greater or equals to, you already know, is shaded. That means it's closed. And it's greater, it goes this way. So it combines with this one. You can see that. So here, I'm trying to tell you that since this is combined, you have x is less than, that means 8 over 3, okay? 8 over 3 is greater than x, okay? So that means x is less than 8 over 3. And the same x is less than, and then the same x is greater than that. So here I can say -2 is less or equals to x. That is what it means, right? So if that means that, let's see the combined state. So x is greater or equals to -2. That means -2 is less or equals to x. So -2 is less or equals to x. And that same x is less or equal, that same x is less 8 over 3. So less than 8 over 3. You can see this is combined. You can even see it from the number line that is combined. So once you see it from the number line that is combined, you can do the combined form of it. So this is -2 less or equals to x and less than 8 over 3. So the question says, state if the value of x that satisfies the interval is or and. Because this is combined, it is what? And. So for and, the solution is -2 less or equals to x less than 8 over 3. While for or, no solution, because it cannot be apart, it has to be combined. Wow, congratulations to you. You were able to stay to the end of this video. In my next video, I'll be dealing with inequalities involving modulus. Hope to see you in my next video. Bye for now.